Welcome to qnawire.
Okay, so we have the following molecule reacting with sodium methoxide. And recall that if we have a secondary substrate, as we have here, that we cannot rule out SN1, E1, E2, or SN2. So we look instead to our nucleophile / base, and that methoxide is a strong nucleophile and a strong base. Right, which tells us that it would be possible to get both substitution and elimination products, right? Specifically, we should expect SN2 products and E2 products, right? So we will draw multiple products for this. There's not only one product. If we have a solvent, that could influence our decision into selecting SN2 over E2. For example, polar A product solvents will favor SN2, but we don't have a solvent in this case. Okay, so if we're talking about SN2, and recall that the nucleophile that we're really talking about isn't sodium methoxide, it's simply methoxide, negatively charged, that an SN2 reaction would in fact invert the stereochemistry about the carbon with the leaving group, our bromine. So if I were to redraw our substrate in an attempt to draw the SN2 product, and I attach our methoxy, one way to indicate that we have inverted the stereochemistry would simply be to swap the wedge to a methyl with a dash to a methyl. And this would represent a product in which the stereochemistry has been swapped upon installation of the methoxy. Right? So this would be the SN2 product. Now, as we noted, there is a possible E2 product. In fact, there are two possible E2 products. Recall that this methyl group has 3 hydrogens, and that there is 2 hydrogens on this carbon, and that in either case, we can form a double bond between the carbon which bears the leaving group and a neighboring carbon with a hydrogen, i.e. we can form a double bond there, or we can form a double bond here. And so either of those are possible products of E2. Given that this is a small base, the major product would be the more stable product, right, which would be the more substituted alkene. So the major elimination product would be redraw the substrate. We no longer have bromine. We do have a double bond between the carbon, which will bear the bromine, and the neighboring carbon from which we abstract the hydrogen, and our methyl group would no longer be on a wedge or a dash because it would be stuck in the plane from the double bond, right? Okay. Next, consider that of this particular product, we could also consider a trans variant in which the cyclohexane group and the methyl group would be trans to each other rather than cis across the double bond. Like so. This would actually be a more major product than the less stable cis product. And then finally, there is the E2 product when we form the double bond between the bromine, carbon which bears bromine, and the terminal carbon. Like so. Okay, so these are the 4 possible products you can get upon a reaction with our secondary bromoalkane and sodium methoxide. Note that there are no cis-trans variants of this final alkene because since we have 2 hydrogens on the terminal carbon, this is not a stereocenter, right? You need 4 unique substituent, you need 2 unique substituents on each side of the double bond, which is not the case here.